Welcome to The Kingstonian, a podcast that profiles people who are passionate about what they do for a living, what organization they belong to, or the community they are a part of. Here is your host, Dave Cunningham.
Thank you, Steve. Hello, everyone, and welcome. We've all heard about artificial intelligence, robotics, and human-machine interaction. AI helping us do research more effectively, robots finding packages in giant warehouses, and humans sitting in their self-driving cars. Those are just a few examples, and they're coming at us more quickly every day. Right here in Kingston at Queen's University, the Ingenuity Labs Research Institute has pulled together individuals from various disciplines to work together in the same facility to create new systems and machines to help enhance the quality of life for all of us. To help navigate this new approach to research, I've asked Ramzi Asfour, the Associate Director of Administration for the Institute, to join me. This episode was recorded in November 2023. Ramzi, welcome, and thank you for taking the time to join the podcast.
Yeah, thanks for having me. Happy to be here.
Now, I'm told that you are quite passionate about the work that you do with your colleagues at the Ingenuity Labs Research Institute, located here in Kingston at Queen's University. So let me start by reading you something I found online whereby the Institute describes itself as an interdisciplinary initiative focused on combining artificial intelligence, robotics, and human-machine interaction to create intelligent systems and robotic machines that enhance human productivity, safety, performance, and the quality of life. A lot in that description, but I would guess that one of the more important words in there is interdisciplinary. Would that be correct?
That's right. So why don't I clarify a little bit about my role? I'm the associate director there. I'm on the administrative side, so I manage the space, the facility, the equipment, and help manage the research projects. I support the research being done by our group of researchers. So on the interdisciplinary part, we have up to or about 40 researchers now that are part of our group. And so they're faculty that come from all 5 engineering disciplines at Queen's. So electrical computer engineering, mechanical engineering, mining engineering, chemical engineering. I forget the 5th one. But we've also have members from the School of Computing, the Business School, School of Drama and Music, Faculty of Education, and Faculty of Law. So all those faculty members are part of our group, and we're set up to collaborate together in multidisciplinary projects. We share equipment, we share space. A lot of the researchers are co-supervising students from at the master's level, PhD, and postdoc level.
Now, is this different from some other institutions where you have all of these people working together from different disciplines?
It's certainly new at Queen's. It is pretty unique on the Canadian scene, I'd say. Other groups have researchers that are grouped together more virtually, but in terms of a facility and in terms of the level of engagement and collaboration, I think we're fairly unique on the Canadian scene, at least.
I read somewhere that you have 12,000 square feet to play around in.
That's right. So we're very, very fortunate. We're in our 5th year of operation. We got kicked off by a very generous donation from a Queen's alumni, Mr. Bruce Mitchell. He told us to go big on robotics and AI, and so he helped us kit out our space. We've got a fairly large lab facility. I don't know if you're familiar with university campuses. They typically have a lot of walls, a lot of small rooms. It's very hard to do big things in tiny rooms. Mm-hmm. So we are very purposeful in the design of our space, where we have a very large open area where we can do big things. It's we're not going to build any walls. Everything is on wheels, multi-configurable, multi-use space. So we can have a lot of different projects operating at the same time and be flexible enough where we can accommodate different types of projects happening at the same time.
Now, a few years ago, and I use the word few in not really accurately, but I did spend a lot of time in those little rooms with all the walls on the university campus. Lot to talk about here in terms of the kind of work that you're doing, but I'd like to know how you got here. What's your background in terms of getting into Queens and taking on the role that you've taken on?
Well, it's been a long path to get here. I did my undergrad at University of Waterloo in mechanical engineering. I spent a good deal of my early career in the manufacturing environment. And with that was the boom and bust cycles of the different recessions. And both unfortunately and fortunately, I got laid off twice early in my career. And so that got me thinking about pursuing business. And a few of my undergraduate classmates went on and to do MBAs. And so I sought that path. But if I want to be a business leader, if I had entrepreneurial ambitions at the time, I needed to get some business knowledge. And I sought out the Queen's MBA at the time. It was the only program that offered 1 year. I was already in my early 30s. I was more comfortable with losing a year's worth of income versus 2 at the other programs. So that got me to Queen's and managed to stick around ever since. So I received my MBA in the pit of the recession in 2009. I was fortunate to be able to do some consulting at the business school, and that led to an opportunity with a technology transfer office at Queen's. So I did some work there in terms of managing technology portfolio and intellectual property assets. And this opportunity with the Ingenuity Labs Research Institute came up, and I was lucky enough to get the job.
What fires you up about working at the Institute?
Well, we've got some amazing things happening there. It's actually kind of like a startup environment. We're trying to, a big part of my job is to help us achieve sustainability. So it's kind of like we've received an investment from a group, and we're trying to make something go and be sustainable for a long time. So that's fun and exciting. We're building something where we've got a target. We're going to go there. We're constantly growing. We're making our mark on the Canadian scene. We've got really cool technology and some excellent researchers doing some amazing things.
Now, to get at your passion for what you are doing, we need to spend a little time talking about some of the things that your colleagues are doing at the Institute. And I guess before we go any further, I'd like to let you know that you're talking to a guy that has a BA with very little science background. So keep that in mind as we're talking about this. One of the things that I saw when I was looking at one of the videos was the fact that your institute put some sensors in the Waban Crossing. Now, the Waban Crossing, for those who don't live in Kingston, is a bridge that takes people from one end of town to another. It has been long in the making and was finished not that many months ago. But you guys are, somebody at your institute put sensors in the bridge. Now, what are the sensors supposed to do?
So that's the 5th department of engineering that I forgot about, and that's civil engineering. So my apologies to that group. So that project is led by Dr. Neil Holt and Dr. Joshua Woods. They're civil engineers looking at structures, and a big part of their work is applying fiber optic sensor networks. And so if you think about a fiber, it's basically a long glass tube that's very thin. And as it deflects, you can measure changes in the strength of the laser signal that's going through it. So that effectively, if you glue it to a structure and the structure bends, it becomes a strain gauge, and you can measure how much it bends. If it's vibrating, you can detect that in the light signal. So what they've done is they've wired up the bridge with fiber optic signals. You've got some wireless transmitters to the cell network that would collect that data and transmit it to a dashboard that they can observe the data, observe the behavior of the bridge over time. And that information will feed future designs of bridges. It'll feed the maintenance cycle on the bridge, how it's behaving over time, through different load cycles as vehicles go over them, through the different seasons, hot in the summer, cold in the winter, freezing temperatures. So that will inform, smarter designs in the future.
So does it help you looking after the bridge itself, or is it just to look at what may happen with bridges in the future?
A bit of both. I mean, the data will inform what's happening with the bridge, inform maintenance cycles, prediction, how long is the bridge going to last? And then it'll inform future design. We've got a number of different projects around civil infrastructure. One of them is using an autonomous drone to inspect bridges. So having basically a little small drone, quadcopter, that's flying around, automatically navigating and inspecting the health of the bridge. So this is in addition to the work on the Woburn Bridge. So not only are we using fiber optic to detect what's happening on the bridge, but we're using flying vehicles and remote sensors to inspect what's happening on the bridge. The same fiber optic technology can also be applied to railways. So we had a project with a rail operator where we built a robot to install the same fiber optic line on kilometers of railway. And so it's a railway is a big rusty piece of steel, and the robot was able to clean the surface of the steel, lay a bead of glue, and adhere the fiber optic line. And so in a test facility in Ottawa, they had two rail operators try to lay the fiber optic line on a 10-meter stretch of rail. It took them 2 hours. It was very inconsistent. It was a really hard job for a human to do. The robot did it in 10 minutes, very consistently, and the quality of the adhesion of the fiber optic line to the rail was excellent.
Now, we're talking about an autonomous vehicle here, correct? That
Mostly
worked
autonomous,
on the...
yes.
Yeah, okay. So these things have been used in mining and construction as well, have they not?
That's right. So, go ahead.
I was just going to bring in the argument that is really not an engineering argument, but it's the business of you are developing autonomous vehicles and robots to do things that people normally did. And so the argument would come up that, okay, well, you are taking jobs away from people. And I don't know if that plays into any discussions you folks have had.
Yes, it does. So we come at it from a couple different angles. One, the example of laying this fiber optic line on kilometers of railway, it's a really tough job for a human to do. It's a hazardous environment. If you think about, trains that are going by, if there's some miscommunication about which train is going where, or a gate wasn't opened at a certain time, or somebody didn't get a safety notice, the humans working on the rail could be at risk. So having a robot doing it is better. And the robot, frankly, will do it much more consistently. It will never get tired. It'll do the same thing over and over again. So the quality of the output will be better. In the case of an underground mine, it's a very hazardous environment. We've all seen stories over the years of miners trapped in underground environments, some of them not surviving, and a rescue operation taking weeks just to get them out. So putting robots in there is safer for the humans. On the flip side, there's an interesting paper that came out of Statistics Canada, authored by an economist named Jay Dixon with collaborators in American institutions. And he did a study about businesses that adopted robotics. And what they found is that businesses that adopted robotics actually employed more people. But the mix of the people they employed were different. So we had less managers, less people with MBAs like me, and more doers. People who were more on the shop floor, people who worked alongside with the robots, and then people who maintained and worked on the robots. And their productivity was higher. So it doesn't necessarily take, robotics will take some jobs away from people, but it also create newer jobs and allow people to pursue different things, things that are less repetitive and more intellectually stimulating.
This may sound like a very basic question, but let's go back to the railways for half a second here. So you have a robot who is going along the track, fixing the track or examining the track. The person that's controlling the robot, or is there somebody that is controlling it at the same time, or is it programmed to do a certain thing and there isn't a human who's looking after it while it's doing the work?
It's programmed to the human will set it up, put it on the rail, make sure it's running the way it's supposed to, and then we'll just set it to go and meet it at the other side of the target distance. So if it was set up to run 5 kilometers of rail, the human would meet it at the other side. And a rail is a pretty controlled environment. It doesn't have to steer. It just needs to follow the rail at a certain speed and lay down the bead of glue and tackle the joints as it comes along. So that's a fairly controlled environment for a robot to do. So it doesn't need to be supervised, but a human can check on it from a distance and not necessarily be there as it's working.
How long has this sort of thing been going on with respect to checking the tracks of a railway?
I think it's been done in different areas of the world or using different techniques, but this was new capability that the Canadian rail operators wanted to explore. There's a big question about how well this would work in winter and how long the adhesion of the fiber would last on the rails. Mm-hmm. But it's certainly the information that the rail operators would get, what is the maintenance cycle? Where do they have to fix rails right now? They don't know until there's some event that maybe somebody goes by, checks out a rail, or they detect some anomalous behavior with trains. Mm-hmm. And then allow them to see where they can operate faster, where they can load up the trains heavier, or where they have to go slower, where they have to run lighter loads. So it gives them more information to make smarter decisions about how they operate on the railways.
Now, another fellow that is working at the Institute has some background in sending devices up into space. And I'm not sure exactly what kind of devices he is sending or has been working on, but I'm thinking of the different vehicles that have been put on the moon and sent to Mars and that sort of thing. So what is that individual working on?
I think you might be referring to Thomas Sears, one of our PhD students. He came from a background in space where he was building a part of a group that built satellites. And his body of work was to develop a mechanism that would allow the burn up on the satellite on reentry into Earth or into the Earth atmosphere. So you wouldn't have any big chunks of satellite falling down. It would all burn up. And so he would set it up. This device would set it up so the satellite would come down. Thomas isn't currently working on space. He's working on using his background on applying it to autonomous surface vehicles, so autonomous boats, and seeing how he could use robotic techniques to understand wave action and current in the wind and the interaction of the three, and allow better autonomous navigation of surface vessels on the water.
Okay, the other thing I read about was, and I don't quite understand what it was being referred to, but these are robots that are being sent into areas where it may not be safe for humans to go. And we talked about mines as one particular example, but I had the impression that these robots were going elsewhere, but I'm not sure if I had that correct or not.
Yeah, so the bridge inspection scenario, for example, if you're trying to inspect a bridge over a highway, it's fast-moving vehicles. Typically, public works people would have to set up some scaffolding and have somebody climb on it on top of this fast-moving traffic. It's a hazardous environment. So inspecting the bridge in the first place, having an autonomous drone fly over it is safer operation. We're also looking at construction sites where, again, it's a very unstructured environment. It can be hazardous. We can have robots going around inspecting it. Providing information to the building information management system to make sure that things are going according to plan. The builders or the construction workers are putting things where they're supposed to according to plan. So that's another environment. We also talk about exploring using smaller robots to explore things that are also hazardous, like the fuel storage equipment at airports, or even inspecting the fuel tanks in aircraft. We're looking at potentially exploring ballast tanks of large shipping vessels and making sure they're okay using robotics. So those are the type of areas we're exploring right now.
So I'm going to take you to the fantasy world where most of us have gotten our perception of robots, right? So watching movies like The Terminator and iRobot and things like that, where the robot has a human form. And I've seen news stories that have been out there of robots that look like dogs. Mm-hmm. I haven't seen too many where they look like humans, although I imagine there are still some. Where are we with all of that in terms of developing robots that will look like human and do more things that humans do in everyday life as opposed to the dangerous, hazardous stuff?
Well, I'm not sure. I could tell you a little bit more about what we have.
Yeah.
Our students did a fun Halloween video where they dressed up our robots and put together a fun Halloween video. So if you can search on YouTube, Ingenuity Labs Halloween 2023, you'll see all of our equipment. So we've got a robot boat, we've got drones, we've got wheeled vehicle robots, and we've got 2 little robot dogs. We have 3 robot manipulators, arms. How we're using them is in different ways. One way is we've had Dr. Matthew Pan join us from Disney Imagineering. So his area is in the entertainment sector and human-robot interaction. So he's developing works around using virtual reality and having a robot interact with human in a virtual reality setting. So one example would be if you're familiar with Star Wars and the Force grab, and you've got to grab the lightsaber from a distance. He's worked on a setup where in the virtual world, somebody's training to be a Jedi and they're reaching out, and virtually there's a lightsaber that's shaking and they're about to draw it in. And in the real world, there's a real physical robot next to the user holding a real tangible lightsaber. And at that moment in the VR experience where the user grabs the lightsaber, the robot sticks the lightsaber in the person's hand. So it's a very rich, very compelling, it's a very real kind of experience for them. So we're looking at developing that type of setup into different areas. So again, exploring the entertainment sector, what can we do in virtual reality? How does that apply to non-entertainment areas? The technology that goes into that and tracking the human and what's happening in the virtual environment can also lead to safer working areas where robots can track how people are moving in a workplace setting. So right on a manufacturing floor, we've got a segregation of robots and humans. The robots are behind cages, the humans don't go near them. But once the robots understand how people are moving, then you can have a safer environment where you can have more close proximity between the 2 types of workers and have a safer environment for people. We can deploy human robots interactions, for example, in baggage handling situation at airports to address some of the labor shortages they're seeing. We can deploy human robot interaction in virtual reality or augmented reality training for athletes. If you think about baseball pitching, there's already been an example of augmented reality batting cage. Maybe we can apply that to hockey or other type of performance athletics. We can apply to theatrical applications as well. So we have a member, Michael Wheeler from the School of Music and Drama, looking at applying robots to theatrical applications and live digital arts. And so how can you have that rich real world plus virtual reality world experience as well?
Where does something like, I don't know if you went to Fort Fright at Fort Henry during the Halloween period.
Yeah, a lot time ago.
So they have, I don't know whether they're called animatronics or they look like robots who are all dressed up to look like scary people and jump out and scare the people who are visiting. Where does that fit into? Is that a very basic minimalist kind of robot?
Yeah, I would say that's a pre-programmed interaction, and it just sort of, it's more of a timed event. Where we might go is, for example, it's how you, I don't know if people are familiar by now with ChatGPT and how you have a conversation with a robot or with a machine. The interaction with ChatGPT is very human-like. It feels like a conversation that you're having with a machine.
I was just going to go there. That was my next topic.
Amazing. So we can apply that same conversation to systems and machines. So we can talk about a robot in a crowd, say something like our Boston Dynamics Spot robot. You could say, hey, find me a male about 5'9", balding with a black top, glasses, and jeans in a crowd of 100 people. And then the machine can understand what you meant and go try to find that individual or find a different object of a certain description. So this is where the language models coupled with robotics can give you the ability to interact with the robot without actually knowing how to program or doing any sort of computer science. So it now becomes a very usable piece of kit for the majority of people who don't have engineering degrees or knowledge of computing.
You brought it up, so I'm going to sidetrack a little bit here and talk about the dog.
Mm-hmm.
We've seen news stories about this particular invention, and I'm wondering, what is it used for? What are the plans for something like that? What would you do with it?
It's a very good piece of equipment that was developed over 30 years by Boston Dynamics through all their research work with the U.S. military. This led to this commercial product. It's a very good off-the-shelf platform that can go on unstructured environments. So you don't have to have a stable road. You don't have to have big wheels to go over bumps. It'll just walk over it. It's stable. It weighs about 70 pounds, the size of a big dog. It has a payload of about 30 pounds, so you can put stuff on its back. You can put an arm. You can put different computing on it, different sensors. We purchased it to look at the areas like the construction environment. Something's very unstructured. How do we get a robot in there to inspect its environment and perform certain tasks? We haven't got to the construction environment yet, but we've used it in applications where you have the human-robot interaction. So when people see the robot, some people have a very positive interaction. They're excited about this neat piece of technology. They want to get up close. They want to touch it. They assign it a gender. They start giving it a name. They start talking to it like a dog. They laugh. They're happy about it. Some people just want to run away. They think it's very freaky. They don't understand what it is. And they're hiding behind somebody else. They're turning sideways. They're ready to run. So one area of work was teaching a robot how to understand what type of person it's interacting with. And based on what that type of person is, whether it's favorable or fearful, it would approach that person differently. It might behave differently in terms of how it walked, whether it takes a direct approach or a sideways approach, the speed at which it would approach the person. So that's an area of work that we're using it for. Another master student put a microphone array on its back to do directional sound detection and using it in a situation of maybe search and rescue application where the robot's going to explore an unknown environment, something it's never encountered before, trying to find a source of the sound. And so it could be potentially a person calling for help in an avalanche or rubble as a result of an earthquake or some other search and rescue event. It could also be the sound of a chainsaw in a forest, a remote forest, where the robot will autonomously navigate on its own to localize or to find a source of the sound.
It seems like the pace at which these things are being developed is speeding up. Is that a fair assessment?
Yes, I'd say so. I think the number of options available for anybody to acquire a robot and start working on it, I think there's a lot more options out there. We have another robot dog by a Chinese manufacturer named Unitree. You can buy 5 of them for the price of the Boston Dynamics Spot robots. Different capabilities. It's much smaller. The battery life per run is a lot shorter, but it's accessible. It's more accessible to more people than the Boston Dynamics platform. The cost effectiveness of compute. So if you're trying to do AI work in terms of training and run different models, say for object detection or language models, it's very accessible now. It's very easy to interact. The tools are very easy for people like me with basic computing skills to be able to pick up something and run a model and get it to do what you want. It's getting a lot easier for people to pick up the technology and kind of do some cool things with it.
We mentioned AI a little while ago, and we're talking about artificial intelligence. And for the general public, I think their exposure to AI has been focused around a couple of different things. One of them is recently we all heard about the writers' strike and the actors' strike in Hollywood and the fears that both groups had in terms of artificial intelligence taking away their job because it can recreate scripts or recreate voices and pictures of the actors and things like that. It's also been talked about in terms of students using it to write their essays for them. I've even used Chat GPT to write some of the introductions to these podcasts. So, how is AI being used in an institute like yours in the lab?
Well, that's a big question. I think the AI group is a big chunk of our group. They're approximately half of our 120 plus grad students. The applications that we're tackling are very wide and very deep. So we have a fairly sizable group that's looking at natural language processing, so the technology behind ChatGPT, but they're looking to apply it in the legal domain and bring in AI tools to help with conflict and dispute resolution. So they're applying it to develop open source tools, so open justice, that makes it accessible for anybody without deep pockets to take advantage of technology and use it to help their settle disputes without having to pay lawyers $400 an hour to resolve the conflict.
Are we talking about using AI to do the research? Is that what I'm just trying to get
right.
the relationship here?
So one example would be, say you and I have a trademark litigation or trademark infringement case. And you, Dave Cunningham, you said, Ramzi Asfour, you're using my trademark in a way that's not the way it's supposed to. You're infringing on my trademark. I served you a notice. And so I would say, hang on there. I'm not doing anything wrong. I'll read the notice and I'll get my lawyer, and then I'll have my lawyer talk to your lawyer. And then we go do that for a number of times. We go through a discovery phase. We maybe go to court. We get mad at each other. We threaten each other and pay our lawyers lots of money. This tool could potentially say, I could plug in the characteristics of what you're charging me with into the tool. The tool would say, well, Ramzi, here are 5 to 6 precedent cases that are similar to what you have. Here's what the outcome was of them all. Here's the average time to settle. And here's the average magnitude of the settlement. And then I could say, okay, maybe I should just pay Dave because he's kind of right.
Yeah.
Or say, well, Dave, this is what I found. I don't think I'm in the ballpark of what you're talking about. Let's figure this out without us losing our shirts trying to settle this dispute. So it just gets us to a point without having to spend a lot of money, and where we can have a meaningful discussion about coming to terms with what we're doing.
What other things would you be working with in terms of AI?
So we have a very big computer vision group. So they're looking at applying those technologies to autonomous navigation of robots on the road, in the air, and then potentially on the water. So we've got a fair group that's looking at how robots navigate autonomously without the use of GPS. So GPS is a very good piece of kit or way to localize. You've got satellites that are orbiting the Earth. You need at least 3 of them to identify a single point. They're known locations, and with the right technologies, a right piece of hardware, you can get down to centimeter accuracy. But what happens when a robot's in a space where it can't get the full view of the sky? So say in the middle of a big city like Toronto with large tall buildings, or even somewhere like the Queen's campus, there are spots where you can't get full view of the sky. How do you get autonomous navigation? How do you make sure a robot doesn't crash into a wall or make sure it follows the path it's supposed to follow? Well, those technologies can use computer vision. So it's called visual odometry. So it would navigate just like you and I would. It would identify features visually and say, I'm going to track that feature where it's going. I'm going to navigate by these sets of features. So that's using computer vision AI models. We've got another researcher, Michael Greenspan, who's got a very long, storied history in computer vision, really cool technology. He's using AI in concurrence with manufacturing systems for a bin picking application for a robot. So if you think about parts coming off the manufacturing line, they fall into a bin. how is a robot with a gripper understanding how to pick up a part that's laying a certain way and put it properly in the next stage or a pallet that's going to go on. That takes a bit of skill to train a robot. They're using AI to do it, but they're doing it in a way that speeds up the manufacturing process. So if you're a mechanical designer, you're designing this part, you'll send Michael and his group the 3D model of the part. They'll understand what it is, and they'll put it through what's called a synthetic data set generation. So they'll simulate through computer software what this part would look like as a bunch of parts in a bin randomly falling in. They'll use some software physics engines to simulate how the parts will fall into a bin, and they'll render that in a photorealistic rendering. And they'll use those renderings, those images, to generate a sizable data set that they would train an AI that would teach the robot how to pick up these parts in a bin. And this could all be done virtually without a single part being manufactured. And as the manufacturing facility is ready to roll out, the robot would already be trained, it would have the AI models built into it, and it would be ready to go from day one. So that's how they're using it for that application. We've got a different researcher named Elliot Ahmad, who looks at teaching computers how people are feeling. So he could use that application into taking multiple types of information, so audio, video. They can do thermal imaging as well to see the stress level of people, and use that information to create really good workplace environments, or understand stressful environments. How do you put that into, say, like a clinical simulation setup where you're training field doctors who could be in a very hazardous, very stressful situation? How do you train them virtually in a very safe manner to manage those stressful environments, manage those difficult situations, and still take care of their patients in the appropriate desired manner? That type of work is Ali's involved with in association with another researcher from chemical engineering, Paul Hungler, who does a lot of virtual reality research as well, and they're collaborating with a clinical simulation lab at the Faculty of Health Sciences as well.
I think a lot of us are sort of concerned about some of the things that are being taken over by machines. And I think once we get a better handle on just what they're doing, we don't have as much fear. I'm going to throw a very simplistic, what I think is a robot at you, and that's the trolling motor on a fishing boat. And if you can program the trolling motor to take you from point A to point B and then back again continuously, and it runs by itself, and you don't have to do anything. So in my mind, that is a bit of a robot or an autonomous machine in some way, correct?
Yes, I would agree with you, yes.
It doesn't really help you catch the fish, but it takes you from point A to point B and back again. Where's this all going? Do you have a sense, in a very general sense? I know you must have those kinds of discussions from time to time, planning out the future.
We have discussions about what could we do, what the coolest things are. You have to keep in mind that we've got people who are practitioners of these things, so they understand the technology is very intimately. I know just a surface view of what they know in depth. So they're not afraid of it. They talk about it at a much different level in terms of where this could go. Our institute, we're built to enhance the quality of life. That's where we want to go to. How do we use robotics and AI? It's going to be everywhere. How do we apply them in ways that improve our lives? So say, for example, the city of Kingston, this place where we live in, sidewalk heaving is a big problem. People are tripping over them. People get hurt. They sue the city. If the city could, they would survey the sidewalks every single season and address the sidewalk tripping hazards every spring once the ice thaws, and then just save people from tripping over it. But surveying the sidewalks every year is really, really expensive, and this, our citizens aren't going to have the appetite to pay more taxes to ensure that Public Works has all this type of information. It's the same with road quality. It's the same with other infrastructure. So robotics and AI can help. acquiring that information in a much more cost-effective manner. So if you have a sidewalk clearing vehicle, for example, that clears the sidewalks, they do it as an operator that runs it. If you add a few bits of sensors on there, something like inertial measurement unit, the same thing, the same type of chip that's in our cell phones that detects which way the cell phone is pointing. That can be used, and with some smart analytics, you can figure out where the big bumps are in the sidewalks as the vehicle's clearing it and identify those as potential tripping hazards. And all that information can be sent centrally to Public Works, and then with a smart piece of technology, they could identify those hazards every year. Yeah. But it takes somebody like a person who's part of our group to look at that system and put the sensors on it and figure out the right math and the right software to get that right information out and help the city put it. It also takes somebody from the business world to say, okay, I'm going to build a business around this type of stuff and sell it to all the municipalities. And at the end of the results, if we're successful, all our cities and towns and municipalities would have good information to keep our citizens safe. It's the same with road hazards. We could have the sensors on buses, the transit system, and they would kind of go around the city and identify where roads are deteriorating faster than we anticipate, or help Public Works plan ahead. So this is where we think it's going. We're having high levels of immigration to address a severe labor shortage in the marketplace. We don't have enough construction workers. We don't have enough tradespeople. We don't have enough workers, period. So we could fill that with low-cost immigration, or we could use it also with combination with skilled trades or skilled workers, applying robots and AI to different areas that are currently you can't find enough workers for.
Mm-hmm. All sounds very fascinating, very exciting. I can see why you are so passionate about what's going on at the Ingenuity Labs at Queen's University. I want to thank you very much for your time today, Ramzi, and all the best going forward.
No, I appreciate the time. Thanks for having me. And I would say to our community and your listeners, just find us on YouTube, find our video channel, and we're posting there regularly. You'll see talks of researchers who are coming to visit us. You'll see activities that our researchers are doing, or our students are doing as well. So they're fun videos. It's meant to engage a lay audience into aspects of our work and get them interested in what we're doing. I'll also say, come check us out at Science Rendezvous this coming spring and summer. We're always there. We always bring our robots as well. We're happy to engage with the public there, and the kids get a huge kick out of seeing the robots.
We'll put some of that content on the liner notes to the podcast so people can navigate to the YouTube channels. Thanks
Amazing.
Again.
I appreciate the time, Dave.
Take care. Bye-bye.
Bye-bye.
Ramzi Asfour is the Associate Director of Administration for the Ingenuity Labs Research Institute at Queen's University. Links to the YouTube videos Ramzi mentioned are in the liner notes. For those of you who have taken the time to listen, thank you. And I'll be back soon with another conversation.
The theme music for the podcast is Stasis Oasis, written and performed by Kingston musician Tim Aylesworth. If you have any questions, comments, or suggestions about any of the episodes, please send a note to thekingstonianpodcast at gmail.com. For details on upcoming guests, follow us on Facebook. The Kingstonian Podcast is hosted by Dave Cunningham and produced in Kingston, Ontario, Canada.